Hello, today we're going to demonstrate a consensus algorithm with one leader and 7 workers. We're going to spool off the leader here. He's going to look for a minimum of 3 workers. However, we're going to also have a 10-second grace period after the 3 join to see if more can join. So we're going to give them the 3 workers right here. They're going to give us a status update every 5 seconds, and they're actually going to check every 1 second. We'll look at that in the code here shortly. Now let's give them 3 more workers just for fun, and let's have this worker just hold off for now. Everyone looks to have joined. Okay, we're ready to go. We're going to do 6 plus 4 because why not? We're going to start out with um, showing a tie. 9, 9. Let's let this person join. 9. All right, we have no consensus reached because we have a tie. Ties do not result in this implementation in a consensus. So let's do 2 times 3. Now we're going to actually have a consensus. 6, 6, 6, 6, 5, 7. Totally terrible client down here. Just hit hello. All right, we have a consensus. The answer is 6. 4 out of 7 workers agreed. This gets distributed to everybody, and now we're waiting on a final task. Now we're going to demonstrate client disconnecting. So we're going to do 3 plus 1. We're going to go 4, 8, 4, 9. This is 1. Bunch of symbols. And disconnect. All right. So it identified, they're not disconnected. Disconnections are handled. There's no heartbeat system here, so they're handled via a timeout. There's a 30-second window when votes can be sent in. After that point, it'll just go with what it has left. There was no consensus reached because this is a very embarrassing attempt at 3 plus 1, which I think is the task. Anywho, and now just a quick demonstration. This is what happens if the leader quits. Everyone gets disconnected. Yeah. Anywho, all right. Quick walkthrough of the code. So this is basically expanded upon the peer-to-peer system we had in Activity 1. We still have the client and server threads that work. We only have 1 leader and 1 worker class. JSON message handler is a small interface for using the client and the server in both the leader and the worker. Round state is an encapsulation of the state of the round that's currently happening. This is basically a helper class meant to reduce the enormous amount of code that was in the leader. The only thing interesting about this is I kind of took a break from doing the synchronization blocks. I wanted to try playing with atomic booleans, so I used that here instead, just because we talked about it in the class and I have never used it. So we've got the getters and the setters here. Just it's not really relevant, but it was fun to play around with. All right, server thread. There's nothing exciting going on here or in client thread. It's exactly what you'd expect with our 3 objects needed to get input from a socket, which is kind of crazy, but anyway. All right, workers are much smaller, so we'll go start here. We have the main method here. We have validation for the arguments, kind of enforcing the protocol that's described in the README and that we already looked over. When it goes ahead and starts, it's going to send a welcome message, attempt to join, and it's just going to sit here, and all processes are going to be handled by the client receiving a JSON from the server and be processed that way. So all it just goes down and waits to be disconnected, basically, or interrupted, I guess, technically. Handle message exactly as normal. This is handle welcome. It just prints it. Handle task. We're basically just printing out what was given to us, capturing a result, and shipping it back to the leader. Handle consensus and handle no consensus. These are just messages to print out the status of what happened. They're honestly could be combined probably, but all is well here. And this is just shutdown procedures. All right, leaders where most of the interesting stuff happens. Up here we have a bunch of, this all gets used in various places. We are enforcing a minimum of 3 workers, so if less than 3 are submitted through the command line, then we'll bump it up to 3. We can use a lot more though, of course. We're going to validate the arguments. I think I already said that. Make sure we're using 3. Give some feedback to make sure the user knows what's going on. Start, we're going to, this is pretty well documented actually, just with the method names alone. We're going to spool off a server thread. We're going to wait for initial workers. We'll go through that in just a second. Once we have all our workers, we're going to go and let them know we're starting. We're going to run the consensus loop. This is where we spend most of our time. As you saw earlier, workers can continue to join. This is just making sure we don't start the first round until we have the bare minimum plus whoever joins in the last 10 seconds. And if we get to this point, we'll broadcast, shut down, and end. So just real quick, we'll go, it's right there. All right, so I want to make sure that we're giving feedback to the user, but we're not spamming them. So every 5 seconds, they're going to get a message. Every 1 second, they're going to check to see if they have the minimum. And after they have the minimum, they're going to wait for 10 seconds more. There's nothing terribly exciting or monumental going on here. It's just a very simple check time, every increment defined up here, do something, notify people, etc. Run consensus loop. This is what mostly is probably interesting. Basically, we're just going to sit in this loop for the entire time. It's going to ask for an input. It's going to take the input. It's going to do a little bit of validation, make sure we're taking a snapshot of the active workers. We're going to go down. We're going to print off what's going on. We're going to generate and send off a payload to all the active workers, and then we're going to use a blocking mechanism here to wait until their response. We get their response, and we go down and we handle it. This is just the check for timeout, status every 5 seconds. These should probably be swapped. I'll swap those. And then finish round is where the actual logic happens. Down here, we're going to take in the information that we got from round state. We're going to do sort of like a selection sort in this area to find the actual highest count in the map. Then we're going to go ahead and see if we have a majority. We want to have at least 50% of the total votes. We also want to make sure we are not tied. If both are true, then we have a majority. We will generate a consensus message and send it off to everyone. If we don't, then we won't have a consensus. We'll send off that message. And we'll show the distribution so the workers can see what actually happened. Down here, I believe these are all helpers. The broadcast is just sending out messages. Leaders shutting down. This is the end of the program. Handle message, handles input, handle hello, handle results, handle disconnect. This is kind of goes to failure. If we have workers disconnect and it puts us down below the minimum, then it will say here that we can't continue and we're going to have to stop. Requested quit. This is just so, because in normal shutdown, it will disconnect everyone and then quit. It'll send disconnection messages to everyone, and we don't want those two processes interfering with each other, so that's why this is here. But this will just disconnect everyone and then proceed, which we didn't actually use because I just canceled it. I didn't hit quit, which is kind of foolish, but not part of the video demonstration. All right, and that's everything. Here's the README. We can just read. You read this to see more detailed information about everything that's going on. With the Gradle commands, you can just copy paste for the video. There will be a video description here shortly if this video turns out half decent. And thank you for your time watching this, and have a wonderful day. Bye.